Alright, welcome back to Meteorology 101. In this video, I'm just going to do I'd like to say a quick analysis, but I don't know how quick it's going to be. Surface chart analysis. So we're going to download the METAR data across the United States. It's going to be probably about 5 hours old or so, 4 to 5 hours old. I already got it downloaded where I'm going to put the surface plots that are reported by the weather stations throughout the United States, about 85% crowded onto the chart, and then we are going to try to find our high pressure centers and our low pressure centers, and then draw the isobars, try to find the troughing, and get an idea of what the synoptic situation is across the United States. Alright, so I'm going to go ahead and put the surface plots up. We got 85% coverage. If I went 100% coverage, we wouldn't be able to see the chart and wouldn't be able to analyze it. So I have to get rid of some of the data so it's not so cluttered. We end up with anywhere from like 2 to 3 or 5 station plots in each state. So there's a lot more than that out there, but we got to use this data for what we can to get an analysis and try to just see where the highs and lows are, frontal systems. We can look at the weather right now. Looks like we got a lot of lower pressure in the central United States, probably like a either a low. I can see some circulation right there, inverted trough maybe creating the rain. We definitely got instability right there along the Mississippi Valley, and then we have onshore flow, low ceilings. Looks like some moderate rain in the northwest. All the red is the really low ceilings or visibility. So we got visibility of, looks like 2 miles over Indiana. And then marginal VFR right around the upper Mississippi Valley. So with the blue state plots, we got, let's see, ceiling, that one's at 700 feet. The marginal VFR is anywhere with ceilings or ceilings between 1,000 and 3,000 feet and visibility between 3 and 5 miles. So these station plot colors give you a pretty good idea where most of your moisture is, where your low pressure system will be, so you can start looking at that general area. So let's go ahead and draw this out. Like I said, I've seen circulation right around this area. I got an easterly, southeasterly flow there, southeasterly flow, and then we're going southerly, westerly, northwesterly, and then northeasterly. So let's see circulation right there. Let's get rid of that. Now let's go low pressure. I'm going to call it, if I can get my mouse from drawing, I'm getting too close. So let me use the regular mouse. We got circulation right here. Our center, we're going to have to narrow that down. Here's a 995 center, 998. So if you're in the 900 numbers, you just add a 9 in front of that, 997.9 millibars. If you get up, you see a 0, that number begins with a 0, you just put a 1 in front of that. It's a 10, so 1008.3 millibars. So we're getting into higher pressure over there. So we got the rotation here. We're looking for that low. We got a 998, 995, 999, 998.9. There's the 995. We're pretty much eastern or western Tennessee is pretty much our lowest pressure. So 995.8, 995.1 right there above that. So let's put our low pressure center pretty much right over here on this tri-state area. And then try to find our isobars. Now on the surface, the isobars are every 4 millibars. So 996, which is, we're pretty close to there, to 1000, 1004, 1008, 1012, and 16. So getting into the higher pressures. Let's go. Let me get a black pen up here. Let's just see if we can see some circulation. Maybe we can pull up a high. So do we see any surface highs? I definitely see some rotation there. Some clockwise rotation. We're looking for clockwise rotation around the high. So it does get a little tricky to find your centers based on those winds, because those winds will shift also with backing on the surface. They can slow them back, speed and veer, and then you got. Plus, you have in a low pressure system, winds circulate counterclockwise around the low, and they go into a low. So as these go into that, around that low, they kind of push into the low also. Same thing with the highs. The high is clockwise around the high, and then out of the high. So your wind shifts, they're not going to be exactly, the isobars are not going to be exactly parallel with the wind barbs on the station plot every time. So, like, for example, we got a calm wind right there, but this is a mountainous area, so you get in the upper elevations, you can definitely get a lot of different wind speeds. So we got 10 knots, 20 knots up here, 5 knots, 15 knots, 25 knots. So we're getting a little windy in that area. So we got, looks like maybe a little bit tighter ISO pressure gradient right there. So as you're getting to them upper wind speeds, that gives an indication of our pressures also. Looking for the highest pressure and rotation around that high. So kind of calm right there. So another thing is right in the center of a high could be calm winds also. We got winds going out that way, so we got divergence there, pushing out that way, divergence away from each other. So you got directional divergence at the surface there. But like I said, this is all mountainous territory, so we're, you know, those winds can kind of go where they want based on the friction of the mountains, being in valleys. That can increase speeds, air sinking down the valleys depending on where a station is, and then, you know, cause of these different directions. So it gets pretty tricky to analyze in the mountains. Let me get rid of those. I'm going to erase my whole screen. You gotta be careful, I guess, drawing onto the. Not going to let me do that, so I'm going to have to erase it. Let's put our low back over there. Now, go back where I was saying I'm going to get a black pen. Black ink on that one. Alright. Start with this low. We see our circulation. Now here we got, what do we say it on 1095, or no, we had 995.8. So we had 995.1 millibars. So if we put that low right there around this circulation, then we can call that like 995 on the low center. But we gotta make sure that's where that goes, exactly where that goes. Okay. So we said 995. We're looking at 996 would be the first isobar that we would see. There's 999, 998. So we're going to stay within that station on 996. 995.8, we're going to stay out of that station because the lower pressure stays inside toward the center. 999, that stays out. There's no pressure reading on this station. That's an automated, like a station that does an automated report, so it just missed the station pressure. Then we have 995. So we said 996, so we can just pretty much take this up. We don't know what that one is. We can just use it and go through it. 997, stay out of that one. That's got to stay on the outside. 995.1, that has to stay on the inside. Then we come back around to 998. So our 995, pretty tight low right there. We'll just call that 995. After I get done, I can throw like a surface analysis up here and we'll see what we'll do a comparison, but let's work our way out. So 995, we got 996. I don't want to cover up any numbers, so we'll call that 96, 996 millibar. Then we go to 1,000. So then 997 is less than 1,000. What's this? 1,014. That's way out there. 998. Here's 1,000. 1000.4, so that's just on the outside of that, so pretty much right next to that station for 1000 millibar. There's a 999. That one stays right inside the isobar. Just scribbled through that one, so let me go back. 999, 1002. So we're looking for 1000. That's got to stay on the outside. So we knew that was the 999's on the inside. 1009. Looks like 1009 right there. I want to hit the wrong buttons here. Let's go. Can't see any readings on that one. Let's see, 1000. We're looking for 1000, so that's pretty close to the 9 there. So we kept that one outside. That was 9 something there. We're still looking for the 1000, 1009. That's 998 right here. So our 1000 has to stay outside of this one, outside of that one. I'm getting 1014 over there, so that's getting pretty high. 1008. So we're on 1000. We're going to go 1004, 1008. So that's going to be a tight. That's going to be pretty tight. We got that 1008 right there. I'm going to have to see where that ends up, because there's going to be another isobar in between these two. So we got to be careful here. 1003, so we're going to stay on the inside of that. We don't have one there. 1006, that's going to stay on the outside. So I'm assuming this is pretty close on that one right there. And then that one stays on the inside. So we're just looking for 1000. We got 1003 right there. That one stays on the outside. I could bring this one just right around there. Now, we could probably just close these off right through here. Then we got 1009. Man, that is tight. We got to go. I can't really tell what that is. See, that's 1009, it looks like to me. So if that's the case, we got 1004 that's going to shoot through here. See our wind speeds. What do we got? 30 knots right there, man. There's a tight pressure gradient. We're pushing a pretty tight pressure gradient through here. So up through here, we're not really, being that tight. That's I could probably bring this one closer to that station to give it a little more gap. But man, with that pressure gradient, you think these wind speeds would be a little bit tighter. So we're gonna go ahead and mark this one 1000. So we got 96, 1000. That starts looking a little messy right there. Let's go. Let's see if we could just do this. I don't know. All right, we had our low. Pretty much had pretty tight gradient right through here, and then we had, so it's 1000, that's 96. Like I said, I'm trying to keep this neat, but I don't think that's going to happen. Maybe I can, let's see, I don't know if I can thin my ink out a little bit or not with the settings on this program. That's probably not working. Let's go 1000, 1000.6. Another 1000 went around that one. 1000 went around that one. So we need to bring that back around. See, I'm just making a major mess here. So this isn't real super easy on this tablet. So let's try low. It's a 996, there's a 950, 995, 998. Let's see here. 999. Alright, so we call that 996. Now we're going after that 1000. Alright, let's call that 1000. Now we're going after a 1004. So we got 1,000.6, 1,000.6, or 1,006 right there, and then we got 1,004.7. So we're just on the outside of that one. 1,008. Man, that's gonna be tight, dude. So we got this 1,008.3 is right on that station. But we're gonna have another isobar right through here. So 1,009. It's 1,009.3. It's just hard to read. 1,009.3. Oh, that's over here, so we're okay. With 1,009, we're gonna go outside of that. 1,008. We'll call this into here, and then 1,004. That's over here. As long as we stay right out of that, and then that one in Mississippi. So 999. I'm calling it out here. I mean, almost looking. We start looking for some troughing. I mean, I'm kind of getting a little bit troughing right there. South at 8.9. We're definitely there. 1,017. 1,009. Stays outside the line. 1,004. So we are troughing right there pretty good. So we got 1,000 and 1,004.4. Almost looks like a 4.4 right there. 1,000. Can't really tell what that is in the panhandle of Florida. 1,000.3 maybe. So that'd be 1,000. It'd be right outside of that station. So we need to come down through there, and then 1,000.4 goes back in that station. 1,007, 1,003, 1,001. So we're pretty much going to come back up over here for the 1,000 mark. It's 1,000.6. That's gonna stay just outside that station, and then we're coming back up into the markets where we were. Okay, so tighten them up. Now 4, and then we're looking for 8. So I think it was 1,008.7 right there. But you could pretty much, the way these charts are, if you zoom into that thing, that line's going to be miles away from that station. So being 1,008.7, you can almost just take it right through the station if you wanted to. 1,006. So we got to go up. 1,008.2. That stays on the outside. 1,000. What's that? 1,005.2. That's got to go in. 1,009.6. So we're way out here now. And we're looking for the 8. Bringing it down. 1,005. 1,004.6. We could brought this 1,004. Since that's 1,004.6, could have came right up around there a little bit further. No, we didn't really have. We had the 1,000.6. So that was the 1,000. So this one needs to go. So that was 04, 1,004. That was 1,000.6. So that needs to go outside of that. So we need to bring that out. Alright, so this is what you do with these charts. You print this out, do this with a pencil, and then you can make your corrections, and then use your marker or your crayon, whatever you want to use. Alright, so we are on, we got 08, now we're on 12, we're going to go 1,010, 1,012, even right there. So that's going to come all the way over to there. 1,013, 1,010.7, we're going to come down. 1,014, we're at 1,012, that's 1,011, so we're going to go between these two stations. 1,011, can't really read that one. then you start getting out in the ocean area, you don't really know, what's happening out there. We got Bermuda. That one's gonna be hard to see what that is. I need to see what Bermuda is. Let's go. Let me exit out of this program just a second. We'll bring that right back up. Let me move this over. 1080. 1008.0. Alright, now get my pin back up, and that should bring me probably a little further off center than I wanted to be. Alright, so now we got another mess. Okay. I guess we're okay there. No, too bad. Let's go, alright, 1008. Man, that is gonna be, that's kind of crazy. Let's go. It's way too far off to be running around. There's another system out here, something going on. So we're gonna ignore that. We're not gonna drag these Isobars all the way out there. It's a big long trough. So we're not gonna do that. Let's go, continue with what we're doing. I mean, if we have to do anything, we can drag this offshore, something like that. Probably should see a little bit more troughing over here anyway with our warm air advection from the south. We got 10 knot winds, warm air being pushed to the north. So we got temperature to 60, can't really tell what's going on, 56 there. So we do have, the warm air to the south, we can push to the north. So we could probably bring all this out just a hair, but maybe so we could place that warm front. But the other thing we gotta look at too, like what's going on out here. Is there a ridge? Is it high pressure? Is it blocking this low? Once you start doing that, then you get this warm air that's being pushed to the north. It's being pushed into that high, and then you got the warm air being pushed up over the colder air, the high pressure system, and then that warm front's going to have to drop down, and you got some blocking going on. Or this is being as deep of a low as this is, that you have an occlusion going on. So if you have a high pressure out here and it's blocking this low, pushing into that, the warm air is riding up against over top of the cold air, then that's where you're going to have a warm inversion. So I'm sorry, a warm occlusion. So an occluded front, if you draw an occluded front on here, so you got to look at your wind directions, wind speeds. We'll do that here in a minute. Let's get our Isobars done, but you'll get an occlusion coming out of the low, staying in the wind shift. Mainly you're looking for a wind shift there because you're in temperatures. I mean, it's hard to tell because with the temperatures because you're just on the surface. So if the cold air is back further, where the cold air and the warm air break is basically going to be where the warm air and is pushed up over the cold air, and then the cold front. Essentially, it's a cold front. It's occluded because you got a warm and a cold front together. That's going to be your line that divides those two air masses, which it doesn't really divide those two air masses because the slope of the cold front is on the surface, the very low part of the surface, then the warm air is up above that. So you're going down through a warm layer from the vertical and down into a cold layer, and when you got warm air pushing up over cold, that's the warm occlusion. So we'll get a little bit deeper into that stuff when we get there. Two, when we start discussing types of fronts. But you have two types of occlusions. Once that air becomes occluded, then you have a cold occlusion and a warm occlusion. The difference, what you're looking for is this warm air mass, the low pressure system, pushing into the high and the high stopping it, or is the high pressure system pushing south, or subtropical high pushing north and pushing up under that warm air. Once that starts happening, then you have a cold occlusion, because the cold air is basically doing the work, not the warm air. So all right, let's get back at this thing. 1008, 1010. We're looking for 12. So we're way up here now. We got to go. There's 1009. There's 1013. We're way out of whack here. We got to go up, up. So there's our inverted trough coming up. 1012.3, that stays out. 1012.2, that stays out. 12.3, that stays out. Drop it back down. 1010, that's got to go inside. 1008, that stays on the inside. We don't have anything here. Nothing there. So just data that doesn't work for us. 1009, 1008, 1017. I mean, that's insane. I mean, now we took a big jump there. So we're at 1012. I mean, this pressure gradient starts getting crazy. So we go 1016. There's 1018. Don't have anything there. 1000, nothing there. 1013. So we're at 1016, 14. All right, 1008. So that stays on the inside. 1014. That stays on the outside. 9. What did I do there? Let's go. What we got? 1012.8. Okay, so we're dropping all the way down into here. I'm gonna leave that one in. 1005. Now what is that? 1008. Alright, 1005.6. We almost drop our trough all the way back down through here. 1009. We're going to bring this one over. What is this thing? 1008. 1005, 1009. We got to bring that down around that station. And then we can go 1007, 1011. Hold it back around to that one. And then this one's going to come back around. 1009. Can't really tell what the other one is. Got a broken ceiling at 20,000 feet. Back around. It's hard to tell what's over the ocean. That's a guessing game. And then 1014 right there. So let's bring it right back up into that. So there's our inverted trough. We're going to be, there's the troughing that's up into the upper Mississippi Valley. We got upper Midwest right there. That's causing all that low ceiling. That's our troughing right there. Now, if we look at the temperatures, we can see where it's crossing over to into this system. We can see if we're baroclinic, barotropic, find out where this warm air advection is, and then we can determine off of that also where our fronts are based on wind shifts, temperatures. Let me get out of here. I just mirrored the screen. Alright, like I said, this is a mess. Now we know we're building into high pressure. What do we have? 1012. Nope, 1000. We're at 16 there, right? No, it can't be. There's 13. That's 12. 13 stayed on the. Yeah, we're at 12. We skipped a 12 here. That jumped up over there. So let me get this out of here. Get a pretty big gap right there, and then let me get rid of all that. Okay. 2. There's our 12. Now we're after 16. We got an 18, 17. We got to stay in between there. We got 13, 18, a 16.3. It just stays on the outside. 17 stays on the outside. 15. So we're at 16. It's 15.5. We're going around that. So we're just going to guess around this, and then that's a low pressure there, so we don't really know what's going on there, and then we can just drop this down. And then I mean, you could have anything going on down in here. You don't really know. The computer can analyze that stuff. It extrapolates it anyway, so you know it could be right or wrong. It can't, you know, a lot of this stuff. If we overlay a low pressure system right over this, it could be way off too. We could be, you know, we're going by the actual data. The computer smooths these lines out and actually extrapolates a lot of stuff to smooth it, make it smoother, make it look like a neater chart, so you can decipher those low pressure systems. But when you get down to the nitty gritty on a station, then you know ours is always right. Now these scribble marks, ignore that. We just got to like I said, print these out, do them in a pencil, and then do them in a marker or crayon and colored pencils, whatever you want to use. And then you have your surface chart. So alright, we go back to 16. I'm calling this one 16. Let's put that down there. All right, 17.3. Stay out of there. 14. I don't know what's at the top. 13. So we're just kind of bringing that off the chart. Then we're coming over here to 13. Bring that back down. Here's a 16. Even right there. 14s. 13, 17, 18. So we are at the 16. We're coming down here. We don't have no data there. 17 right there, and no data there. Kind of shooting right back down. Actually, we're going to go back out of that. What is this? I mean, we have no data. Let's go. Let's get our eraser real quick. I want to see what's behind this. 17. So we're at 16. We're dropping down to the 17. There's a 17. There's a 14.6. We're dropping all the way down. We still don't have any data there. So we're just going to kind of bring us back around to off the chart. Here's our inverted trough. Let's just go. There's a trough right there. Inverted trough out of the low. Let's say we got warm air advection right through this area. And it's pretty weak though, man. We're not having a whole lot of action there. We got a lower ceiling, so I'm pointing this occlusion. I'm saying occlusion will drop a little bit south on that, just by looking at where the ceilings are and the lower cloud heights. It's going to be. I'd have to see what the temperatures go through the isotherms, but to break that down to a perfect spot, but I would have to say drop out occlusion south and then coming into a cold front, and then looking at your wind shift 67, 79, 77, 78. Let's see, 67. Let's see, 83. I mean, your cold front's not back here. You're going to be 22, 27 on your dew points, 26, 46. You got a dry line maybe over here. That'd be all the way in eastern Texas, but 18, 22, 23, 22, 24. So your dew points are pretty low anyway. I mean, it is getting a lot drier out there in the desert. So trying to pull a cold front out of this low. If you drop that conclusion out of there, then you'd have to almost like drop it south and then figure out where's the shift. 79, 67, 77. There's not much of a temperature difference, but that's pretty far apart too. So you're gonna be going frontogenesis there. And what's your temperature advection? Where are your isotherms to cross over, to bring that cold front? I want to bring 72 and 63. So 72. Can't tell what that is. Oklahoma. Let me get an eraser and find out what that is right there. 67. Okay. 72 and 67, not too far apart, but with that 63, you would almost bring an occlusion and then bring that cold front wrapping back around. I mean, this system is pretty closed up. I mean, there's a lot of closed isobars around that low. So when you do that, that's a really mature low, and then basically what you're going to end up seeing is a major pressure increase on the surface. I mean, it's going to push off to the northeast first, but you're going to, depending on the jet support, where exactly that jet is. I mean, this thing's definitely got jet support. Definitely has upper air support, depending on how high in the upper levels this low pressure system goes. Lows start filling from the bottom up. So as we called this thing 995 center, that's a pretty low center. So they start filling from the bottom up. We should start seeing that push more to 1,000, and then start filling and just dissipating. But it's gonna be a little while to dissipate. I'd say that's gonna push all the way up to the northeast with the jet stream, because it's gonna just steer it. And then as long as that jet still has jet support, it could possibly still suck mass out of that low, but depending on what's going on in the upper levels. Sometimes you can get so much mass coming out of the lower levels like this to get to a 996 millibar, 995 millibar low. Air just starts pushing the mass just starts coming off of the surface into the upper levels rapidly, and then you could build high pressure in the upper levels because you're hitting the tropopause, and then that's stopping all the mass, and it's just piling up, and then you get an upper level high over top of this, kind of like a hurricane, but you know this is over land, so obviously it's not a hurricane. And then depending on the stack of that low, like the low center, and then if it stacks back toward the colder air, you know what the tilt of that low is. That helps you judge the intensity of this low. Now, if that low goes all the way into the upper levels of 30,000 feet, then you got a pretty intense system. The mass is just coming out, the jet stream's sucking it out as like a vacuum, and then there's nothing to stop it. The tropopause is not going to build a high pressure, so because you got the jet stream just moving that air out of the way as fast as it's going up to that level, so it's pushing all the mass out of the way and then allowing more mass to come up out of this low, and that's just to allow this thing to keep breathing. So then it can become even more intense. But a 995 millibar low is a pretty deep low. I mean, they will go deeper than that. I think we were in the 950s, 960s on that system over there off the west coast. So that was like broke a record. But when you're over the ocean, it's a whole different story because of all the moisture, the instability, and you can get we got colder streams coming from the north, warmer streams coming from the south on the east coast, and you can get just that will affect them low pressure systems and allow them to feed off of that. So, yeah. All right, let's get back to our analysis, our messy analysis here. Let's try and find this high pressure system. So, like I said, once you get into the mountains, your winds are all over the place. Like when you're at, here's a 15 knot wind, that's okay. 10 knots pretty good. Once you get to 5 knots, you can just kind of be all over the place. 6 knots is or less is pretty much, you can almost go bearable with the wind at a 6 knot wind. It doesn't take much friction to back that wind, so you can have wind shifts quite frequently on 6 knots or less. So 30 knot winds, we know we're pushing out of the north pretty hard. We had 1,016, we're at 1,020 now. Here's a 21, so we know our 20's here. There's a 22, we're going to stay between those. We don't have much data there. 1,018, so the 20's in the right spot. 18, 21, drop over here, come back up. 19, we're going to stay actually around that side of it because the 19's going to stay on the inside. Oh, don't do that. I almost hit the trash button. Alright, let's go back over here. Okay. I guess maybe I can, thickness. Here's our thickness. Let's go down to 1. Let's just see what happens. I'm going to do a test strip right there. Well, that's pretty thin, ain't it? Alright. Let's pull up 1. Now what do we got? I can deal with that. It's a lot better than what I'm working with. I don't want to start over, so we're just going to leave it there. Okay, let me get my eraser. Erase all this stuff here. Alright, what do we got here? Okay, so get back on my pen, and now it's going to look a little bit funnier because 1,016, 1,018, 1,000. Where we at? 1,016, 1,020. We're way over here. We gotta come around. There's 1,021, so we're gonna stay close to that station. 1,016, 13. I don't see those. That's lower pressure. So we're gonna go. We're gonna kind of keep going. Winds blow clockwise. I'm gonna follow that direction and go up. But let me clean this up a little bit now. Okay, if that's the case, we're going to go west. We get 1,024, 1,018, and I'm going to bring this over here. Then we're going to go 19. That's a lower pressure. 1,019, back up 1,026. Man, that's getting pretty strong there. And then 1,019, we don't have an answer there. 1,019, 21, 17, 23, 22. We'll keep that all in the center. I'm just keep going up. 15, that stays out. 18 stays out. 16, 18. Alright, that stays out. And 20. Here, we're just going to go right there. Now, alright, where is our high center? We're pushing this way with a 15 knot wind. We're good there. That's up. That's up. Maybe we don't have a, we have to have a center here somewhere. Like I said, with the mountains, it's kind of iffy anyway, because you get those wind shifts and it's real hard to tell exactly where the high center is. So, all right, 1,020. Let's call it 20. Where are we gonna write that at? So we're not messing stuff up. Okay, 20. 24. There's a 25. There's a 22. We're in here. 24.3. That's down there. That's pretty tight. So we need to bring this and back down and back up. So we got a kind of some ridging going on there. Maybe around a mountain range or something that's influencing that data. And then 26, 25, 24.9, which we're going to stay on the outside. 21, 23, we're going to stay on the inside. Then 22. 20.2. We're on 24, so we got a 23 right there. We got to stay on the inside of, so we're just kind of going right around here. All right, so we're getting closer to our center now. I don't see the westerly flow. I see a 5 knots up, 5 knots down. Like I said, there's a mountain range or something right there that's causing that wind shift right there, that wind shear. You only have 5 knots, so it doesn't really matter. This could have been variable. You download the next data and it's probably, you know, everything's from the south. That's hard to tell, so we don't really pay attention to the 5 knot winds. Alright, I'm gonna come on. Alright, get the eraser now. Alright, we're gonna go back around here, and we're calling that 20, 24. Do we have a 26? Here's a 26.2. That's going to stay on the outside. 25, 25, 29. Alright, so that's going to come all the way up through here, all the way back around, and then we're on a 25.3. So right here. Alright, we don't really see our center, but we're going to go. We get some blue. We are going to go to our highs right there. We're going to go to northern Utah for the high pressure center. Okay, I know that's a mess. Tight pressure gradients down here. We got 10 knot winds. That's not really reflecting that very well. Like I said, mountain range. Manipulating this data pretty good. Get snow in the upper levels. These low visibilities. We got 50 feet for a ceiling. We're in IFR conditions. Got our high and we got our low. We're covered in the United States. I would say probably some more isobars down through here. Let's go see what we got. Let's get black, and then let's go, you know, our thickness line, and then we can go. All right, 1,000, 1,020. Yeah, because that's 16. There's 20. We can go back to 16 because we got a 16.1 there, 13 there, 13 there. What's that? 21 there. So we're going to come over this way. 14 there, 19 there. So we're going to go almost straight out there to the ocean. So, like I said, ocean, we don't know what's going on. We don't have any data here. 2016.1, we're pretty close on that. And then I don't know what's down here at the bottom, so I'm just going to call this. See, that data's missing also, so we can just call this right around here. So we got probably another low pressure center off the coast. All right, now probably some more data up in here. 18, 16.3. We go 16. That's 16.3. That's high. 18. This 16 probably almost come up closer to that 16. But what do we got there? 16.7. So it can't do that unless it went around. That's a 17 right there. So that ain't going to work either. So we're just going to leave our 16 right there unless we go actually 17, then back to 16. Now we dropped down 16.3, and then we got another 19, 12, almost like another system right over there. All right, so frontal placement. All right, first off, let's go. We got this pretty good. Let's go see where we're at, how far off we are. I'm going to throw the highs, lows, and the pressure ISO bars on this thing. All right, close that out. All right, I have to close that for now so I can operate this without drawing. So let's get our surface pressure loaded. Let's computer analyze it. Right, we do got some troughing out this way, troughing to the south. Let's turn our draw back on so we can overlay this and see where we were. Okay, so we're pretty close on a high pressure system, northern Utah. Low pressure system, we should have pushed a little bit south. Well, not actually here. Let's go. I'm sitting here saying we should have, but now we don't know exactly where their high pressure. They got two closed isobars around the high. 1, 2, 3. 3 closed isobars around the low, and then a couple isobars in between that are open, separating that. And then they got, I went around, I closed this off right here. That's what I did. I came back around, then said, hey, we can just go right back around. So let's see, this chart, here's the problem. Let's see, we got high pressure. That'd have to be high pressure to the northeast, high pressure to the west, and low pressure to the south and the south central U.S. We got, to separate these highs, you'd have to have an inverted trough. Someone's got to separate those. I would just close the isobars off, and you don't even have it. You have the inverted trough, but close the isobars off, bring your other system up to the north, and then you have, you don't have to have a stationary front, or you got to have a stationary front or a major shortwave or something that separates those pressure systems. The leading edge of a pressure system, an air mass like that, is a front. So when you get two of them together, you get two opposing winds. The winds around these highs go clockwise, so the winds are out of south or southeast, and then this one would be out of the north and northwest, and then they would oppose each other, and then you would, like these two right here. So you have a trough where you have a stationary front there. Well, coming out of the low, I wouldn't place a stationary front. I would just do an inverted trough. That's to separating your flow, and then go from there. So, alright, like I said, I closed that off. Let's go turn this back on. I closed it off right there. We did go pretty far north, pretty close on their stuff. They went through this station. I didn't. Once you zoom in, how far these lines are actually away from those stations, you can pretty much go through those stations. That's okay. This one here, I brought that one out to a, it's 1012. That was 1011.7 millibar station right there, so I had to go around that. So they should have brought theirs out of that. So that's the details of, okay, there's a little trough right there, inverted trough out of that low. You see the troughing. Now over in New York, you can have a little bit of more cloudiness, or depending on the moisture, and we get the onshore flow, any moisture being pushed onshore, and then a trough with an unstable area that would cause cloud cover right there. So something to look at right there. And we do have low ceilings off of right there, Connecticut, and just north of Rhode Island. So we're not too far off on that. Let's see, we got 1, 2, 3, 4. I called 5 closed isobars. I think they were 4. We got the high. They went 3 closed isobars. That's what I did. We had the low pressure system to the southwest, and then they actually had another low. They placed another low up to the north, right there. I would say just they're calling low. Maybe there's some rotation right there. We got some northerly flow. That could be a low right there. No closed isobar, just an open low to the northwest. So that's okay. Overall, our patterns, we did the corrections. They went out here a little bit to this one. What did they do there? 1008. That one is 1096, 1000, 1004, 1008. 1008's way out here, so they already brought that out. I could have went 1008.9. It's got to stay out. I mean, I could have brought it out just a little bit, that one. But I'm crossing their isobars a little bit because they're going. Let's go get rid of this a second. Just get a see what they're doing with that 1008. They're bringing that 1008 out, back around, and then out again. 1008.9. Well, if that's a 1008.9, that can't be a 1008. So they're wrong on that. That has to go up this way. 1009, that stays outside, has to go up that way. You can't. This little trough, whatever they're doing there, that computer analysis is that's wrong. So frontal systems. Let's go after the fronts. Let's go ahead and erase this masterpiece and start with the frontal systems. So erase that. Okay, so let me get rid of this. We are going to actually not get rid of that. We need that. Let's go. We're going to need blue for the cold front. Now, if this was the case, man, it's going to be tricky. Let's go. Alright. We never got cold air coming out of the north around this high pressure system. That's the leading edge of our cold air mass. High pressure blowing clockwise around the high, pushing out of the high, and then heading up to the leading edge of the cold front. So, where is our cold front? We've got to have something there. Pushing up behind that. We got to have troughing. We got to have a front. We can't have a front separating these two pressure systems. We got to have the front's got to come out of a low. So if there's a low to the north, we could have like a front coming down around that high, but not with a low pressure system in the warm sector. So that makes no sense. So we got to go all this air out of the north, 59, 60, 57, 62. See, there's not a big major temperature change till you get down here to 72. So right about where that trough they place, that's not bad. If you had to place, say, between 67 and 72, I mean, it's pretty weak, but it's there. You know, the temperature difference. You know, 29 on the dew point, 27 on the dew point, no real major change there. 33, 22, 22. So, you know, where are we going to put that front? Back around, coming around that high, right there at this high pressure system. It's more or less of a plateau high. So I'd almost have to go after. I'm going to go ahead and do, here's what I'm going to do. I'm not going to analyze the temperatures. That's going to be way too tough, tracking all these temperatures and analyzing the isotherms. So let's just go ahead and throw those on. Let the computer do that. And then that's going to give us an idea of front placement and what this high pressure system is doing. Is it baroclinic or barotropic? Is the low baroclinic? We know that's probably is a little bit baroclinic. If it's a deep low like that, though, it's pretty mature. If it has an occlusion coming out of it, I would say then that is going to be a mature low, and it can start becoming barotropic. Now, I'll show you here what the difference between barotropic and baroclinic is, because that's going to tell you the health of this system, how mature it is, when it starts filling from the bottom. They always fill from the bottom up. Highs always weaken. So highs weaken, lows fill. But lows usually fill from the bottom. The mass has to come down, hit the surface, increase the pressure. And then that's why it has to fill from the bottom up. High pressure, to lower the high pressure, you got to get rid of mass, either by having more mass come out from the surface than you do converging at the upper levels and pushing down. You have more mass coming out than going in to lower that pressure. So let's go after. So highs weaken and build, lows deepen and fill. That's the terminology with the pressure system. So if the low is intensifying, it is getting deeper. That means that pressure is dropping. If they fill, the pressure is increasing. So it fills from the bottom up. We got high pressure weakens, then that pressure is dropping. If it builds, then that pressure is increasing. You have 1026 millibar high pressure system right now, and that's pretty good high right there. But like I said, over the mountains, most likely a plateau high. I would say if I look for isotherms, I'd probably say they're maybe pretty parallel with these. I would think they'd be parallel with the high rotating, but we don't have very good rotation around this high, so that's the only thing we have to look for. Like, what kind of advection do we have? thermal advection. But over the mountains, like I said, your temperatures can change so much. Those isotherms can just scribble right through the mountains. So the mountains is a pretty hard area to analyze. Now this low, like I said, being a occluded low, with the you got winds out of the southeast, winds out of the south, winds out of the west, southwest, and winds out of the northwest. So now you got the opposing winds right here. You got winds out of the northeast right there, and you got your rotation. And now where that occlusion comes out based on these temperatures, dew points, I'm just saying there's an occlusion there because how deep that low is, one, and two, with these wind shifts shifting that much, you can get wrap around, and then that will bring that occlusion up out of that low, which I'm not sure we have too much of that deep of an occlusion because of the way the wind shifts are too. I mean, I would expect a little bit different wind shifts. These are kind of just pushing in, so you get your shift up here, you got your rotation, that's for sure. But when you're bringing that occlusion out, I would almost, like I said, with the high pressure, you got ridging over here to the northeast, ridging down, kind of blocking that low from kicking out of there. I mean, this ridge will probably weaken and then allow that low to move to the northeast. But look at some models and stuff like that. We can project we can forecast the movement on these things too, but we're not going to do that right now. All right, getting on a rant. Let's go back to let's see, isotherms. That's what we're after. We're gonna go, let's go Fahrenheit, since it's in Fahrenheit for now. Let's see how cluttered it gets. It may or may not get cluttered with the Fahrenheit scale. Typically I just use Celsius, and then if you have to convert that, it's Celsius times 1.8 plus 32, and that'll take you to Fahrenheit. But alright, isotherms, see where we're at. And actually, I just clicked the wrong one. Let's go remove that one, and then we'll go Fahrenheit. So alright, we'll go Fahrenheit on the isotherms, and we have a pretty tight gradient for the thermal gradient. We are baroclinic around the low, and that means that the isotherms are crossing the isobars. When they're perpendicular to the isobars, then that's baroclinic system. Barotropic is when they're parallel to the isobars. So if you start getting, the red dash lines, isotherms just going right along with the isobars, then that's barotropic, and that means that system is weakening. These are almost becoming parallel with these isobars. So we got some advection right here. We got a little bit of advection back here north of that troughing they're putting in there, but like I said, there's really no trough there. It's just that isobar should just drop down. So to place our front, now we're after, let's go see where we got here. Let's go. We almost want, I kept calling this occluded, so I'm kind of like looking at, I want to see a major wind opposing, these winds opposing each other. I want to see I'm just not seeing the, it's not your typical warm sector here, where you got warm air advection and you got a clear, warm front. Like typically, if I pulled my leading edge of the warm air advection would be your warm front. So leading edge of your cold air advection would be your cold front. Now, what do we got going on here? Let's thin that out. We got one thin line, one thick line. It's okay. Now, if I was to pick out my southerly flow, see, we got a westerly flow, southwesterly flow, and we got an easterly flow, rotation right there. I mean, you got it's like almost rotation right there, but like trough, you got troughing right there. So you got that isobar troughing. That's probably true, maybe true right there. We couldn't come all the way out to the Bermuda where that 1008 was, so even though this isobar is 1008, you know, brought it out there, but not likely that there's really no thermal advection in this area. Right here, maybe, but where is, let's go ahead and let's erase this. Alright, I'm calling it right here. So we're going to go, let's go to, I gotta get some purple. Alright, I've seen that wind shift. We got that easterly flow right there. I'm just going to have to push right to that. Actually, right there. We're going to go occluded. Alright, now let's go back to our red. And then with that easterly flow, our warm front. See, this might be a cold occlusion because the warm front comes out. You got a little bit of warm air advection. Let's go back down up to here. Maybe curve that a little bit. Let's go. What are we after? Alright, it's not gonna let me. Let's go. Alright, whatever, dude. Let's go here. Stupid. I think I'm tapping on this thing too fast, and I'm just getting way too carried away. Alright. We just want to erase this real quick. Getting rid of this clutter. So we can see that wind shift. We want to see that one, and then go after our red. Okay. Winds up. Pull that warm front. We got some advection right there. So let's pull that there. Now, warm front. And now we're going after the cold front. We got to have a wind shift. We got winds out of the northwest and the wind on almost out of the south. So where's our triple point? Back here. So that's going to be pretty tough to pull that one off, but we're going to go cold air advection, cold air advection. We got winds out of the northwest, pushing that cold air south. Not much advection down here, but we can bring that cold front up and then back into that trough. So we could probably just take that one right on back. We got some weak cold air advection here, 46.26. Here's another indication right there. We're going to almost just bring that right down around that one because we have a lower dew point there. We have 36, 46. You almost can bring that one right back down through here. Then it has to go pretty much end right there. You're not going to go across this into the high end of that low. I mean, theoretically, you got the continuous front theory, so you could go hit when the computer put that low out there. Right there it is. Then you can go warm front into the cold front. So whatever you want to do there, I don't do that. So we can get rid of all this. I should get rid of all this. I don't want to get rid of the other one, but let's go. We pulled that one. Man, what the, okay, I shut it off. Hit the wrong button. Hit the wrong button. Okay, slow down. Now we go. Alright, I'm just going to end it now. There we go. Cold front. There's leading into your cold air mass. The high pressure system's pushing down to the south. We've got a little bit of occlusion here. This is going more of a warm occlusion just because of the wind shifts, the way that's acting. I mean, if you took that and wrapped it around, then you could make it a cold occlusion, which it may be because it's that deep. I mean, you have a pretty deep low. Those occlusions are hard to analyze, for me anyway. So warm front dropping down with that blocking. I mean, there may be high out here. It ain't really blocking. I mean, you got ridging pushing down, so we got this ridging coming into that low. I'll go ahead and erase that mess. So we're kind of blocking that low until that ridge weakens, goes away. Then that will allow that low pressure system to push to the northeast. All right, this video is getting pretty long, so I'm gonna go ahead. I'm gonna pull a jet real quick. We're gonna actually. Here's what I'm gonna do. I'm gonna erase this chart. I'm gonna pull a jet stream from the 300 millibar. Now, let me get to. I'm gonna blank you out for a second. Here we go. Now, I'm going to go colors of wind. Let the computer analyze in different colors based on the jet maxes. We're going to put the jet stream from the 300 millibar, 30,000 feet on this chart first. Then, let's analyze our pressure. Let's see. We want to see. Might get a little crowded, but let's get first. Let's get a picture of our jet stream. So I'm not going to use all the data. I mean, I should use all the data on the upper air because of that. But here you can see. Let me get my chart, get my draw, get my pen back up real quick. So get rid of this. Go to there, and now. See that? We got them winds out of the southwest. Winds out of the northwest. That one's out of the southwest. And then basically the south-southwest. So they're kind of opposing each other there. But, so you can see that basically we would have our jet stream pushing up all the way up through here. We have to be with that low pressure system. These lines of equal pressure, typically you don't have your wind bars crossing like that over those contours. You know, they're upper air is no friction, so they're usually more parallel. So I don't know what this computer system is doing. Let me get let me erase that real quick. I'm gonna do something else real fast here. We're gonna go with our wind shading. And I'm going to do something else. It's going to take a little bit of time, not much, on that pressure. We're going to do a balanced pressure analyzation on that because we'd let the computer do a balance. We just want to see if it changes those contours. Otherwise, we have to go in there, analyze ourselves. I don't have time for that right now. We're over an hour on this video, so. Let's go. Like I said, it takes a minute. It's not forever, so we'll see where these contours end up. Go from there. Otherwise, we just leave this and we know we got winds out of the southwest and we got winds out of the northwest, and then maybe what we have is the polar jet pushing down to the south and then curling up with a trough. See, there we go. Now we got a deep trough. Now we have ridging here, and then we have a finger of maybe the subtropical jet that's pushing off over the Atlantic. Makes a lot more sense with the balanced height. Now, if we put our plots on here, now we get the winds pretty much following those contours. That makes more sense. So sometimes with the computer it gets confused. It wants to extrapolate everything, smooth everything out, because that's a pretty deep trough right there. So we don't want to, you know, the computer doesn't want to go that sharp. It says, now can't be right. So it wants to make up its own thing, and then it pushes the you end up with the isotax crossing the isobars, the contours, and then that'll get you in trouble. So all right. Jet max, low pressure system was right around here, and that jet max is almost over that low pressure system center. So we got jet support. We have the exhaust. When low pressure on the surface pushes up, we got a major short wave or major long wave trough supporting this low pressure system. It's just sucking the mass out of that. Where the jet support is just like a vacuum sucking the mass out of that low, so that low could intensify. With this ridge, we got that. It's a pretty intense high over there. We got ridging here that's kind of blocking that from happening. We got the ridging in the northeast is pushing down. I'm kind of blocking that low. But with this flow, we got a northerly to north easterly flow. So something to keep an eye out for. This weather patterns are coming through lately. Let's go. We'll explain something here in a minute, but we got what I want to do is put the surface over this. So I'm going to go back, erase this thing again. We're not going to do the contours. We're just going to do the wind. All right, so now we know our jet long wave trough. Winds are out of the southwest, right there over that jet max. So we put our surface pressure. Well, we can't do that right now. Let me go back. And all right, let's do our surface pressure. Now we can see where our lows, highs are, and according to the jet stream. There's the low, there's the jet max. That's our exhaust for the low pressure system. As the low pressure stacks back toward cold air, we have that long wave trough. Then we have support all the way up to 30,000 feet for that system. All right, so the Fahrenheit, let's get rid of that for a minute. Fahrenheit isotherms are going to come up in a minute. They're kind of crowded. There's a lot of them. They're every 2 degrees, so let's just get rid of that. Let's go Celsius. Now, we are baroclinic because these isotherms are crossing the isobars on the surface. So we know we have warm air advection, we have cold air advection, we have a tight pressure gradient. I would expect some pretty good winds through here if these we had those isobars pretty good. I mean, they were tight on our chart. The same chart we analyzed, 30 knot winds. I mean, we're pushing pretty good right through there, right out of the north. So we're cranking real good. But there's your jet support right there, up to 30,000 feet. That low's on the surface. There's your 30,000 feet jet support. Our low stepped back just a hair, and then we got. If you go to 850, 700, 500, the mid levels, you can actually probably see closed lows up to the next 2 levels up at least, and then you'll start seeing that major shortwave troughing to support this thing, and then you got the jet support, and that's a well-developed system. It's a mature low, and we'll have to see how this plays apart with this low pressure system pushed to the north, if it's going to start to fill or start to deepen, get more intense as it moves along, or is it going to start to weaken? What's this high pressure going to do? High pressure goes toward low pressure, so the high pressure pushes into the low and starts to fill it. But we have the exhaust, so how much mass can that ridge push into this high or this low, and then how much of that jet max can suck out of there like a vacuum. Now, if we could suck out more mass than that can put in, and that's just a ridge, that's not like a high pressure system right next to it just pushing mass into this low. It could basically this weekend let that push to the northeast, the jet max push through, and then keep sucking mass out of this thing and get a little more intense. So something to keep an eye out. Now, what I was going to explain is, with these weather patterns we're getting right now, with these high pressures pushing out of the north, we're next week we got a polar outbreak coming out, pushing out of Canada, cold air, cooling things down a little bit. As that keeps happening, and you have those frontal systems that's pushed through, so you have the high pressure that pushed through to the southeast, and then you have a cold front that comes back around that high, back into Texas, even over the Gulf. Then the tail end of that front starts to dissipate, undergo frontalysis, and then you actually have a stationary front as that high basically comes down, starts to turn, and it makes a stationary front because that leading edge of that part of that air mass becomes stationary as it rolls over the east, and then that frontal system becomes stationary over the Gulf. You get a stationary front over the Gulf, and then all you would need is something in the upper levels to create some upper level divergence right over top of that frontal system, and then you could have whole another low just form right over the top of that frontal system. Now, that happens a lot in Texas. Happening over land and happening over water are way two different things. So one thing to keep an eye out is if you get a stationary front going through the Gulf up into Texas, okay, you got one low pushing over. These lows will typically come over and then shoot up to the East Coast. These lows are the same thing. Now look at that jet. We were dropping way down. Look at the wind flow. We got a pretty strong trough right there, even with our jet stream. So we had that deep trough. So now our steering flow was almost northerly. Now you get a low pressure system form along one of them fronts over the Gulf. You got the warmer water. It's not super warm in the winter, but you got warmer water picking up the moisture, and then that jet stream picks that up as a steering pattern and pushes that just directly north, now you can get snowfall all the way through Tennessee, Kentucky, up into the Great Lakes region, and get some major, real significant snowfall. That's what we're looking for. For this winter, I don't know if that's going to happen, but the patterns I'm looking at right now, you know, it's very possible. I'm not saying it is, but it is very possible. This video is going on long enough. I hope you learned something on analysis. If I had any mistakes, point them out. I don't care. I like to learn from my mistakes, get better at what I'm doing. So I want to say thanks for watching. Subscribe, share this video if you liked it, and get your head in the clouds.